Next, we're going to review how to solve radicals. So the first thing you want to do is isolate the radical, or get it alone. Now we have a 4 that's not under the radical, so I'm going to divide both sides by 4. Once you've got the radical all alone on one side of the equal sign, you cancel it by raising it to the power. So if it's a cube root, you cube both sides. If it's a fifth root, you raise both sides to the fifth power. We have a square root, so we're going to square both sides. And then we simply add 3 to both sides. Now with radicals, there's also domain restrictions. You can't take the square root of a negative. So we have to make sure that our answer doesn't make what was under the radical in the first place negative. 7 minus 3 is positive, so we're good. This time when we isolate our radical, we're going to subtract x from both sides. Now when we square both sides, we will have to square the binomial 5 minus x. Do not square each piece individually. That violates order of operations. So what we're going to do instead is, when we square the left-hand side, that cancels the radical. This becomes the quantity 5 minus x squared, which means 5 minus x times itself. Multiplying that out, distributing it, foiling it, however you want to think of it, we get 25 minus 10x plus x squared. Now we want to get everything on one side of the equal sign. The reason we do that with quadratics is so that we can factor and then solve. So I'm going to reorganize this so that the x squared is on the left-hand side like we're used to seeing it, but I want that x squared term to be positive. So what I'm really doing is moving everything to the right and then just flipping it around with the equal sign. So I've got x squared. I'm going to add 9x to both sides, which gives me a negative x. I'm going to subtract 31, which gives me a negative 6, equals 0. So this is t-chart factoring, x minus 3, x plus 2. So my two solutions are 3 and negative 2, setting each binomial equal to 0. However, we need to make sure that neither one of those makes our original equation, or what expression under the radical, negative. If we put 3 in for x, we get 31 minus 27. That's okay. If we put negative 2 in for x, we get 31 plus 18, which is also positive. So both of our solutions work.